Hello and welcome to a new video. This is for Algebra 1. We are moving right along with polynomials to our third lesson in this unit, and this is on multiplying polynomials. And my little one-liner or whatever down here that's supposed to be funny is going to make more sense later on. So I'll bring it back later whenever it's like, but the important thing, I guess, is that we're going to talk about foil today. And we're not talking about aluminum foil, although aluminum foil is pretty awesome. And we're actually not talking about the verb foil as I'm using it here. When you foil somebody's plans, you ruin them. Okay, so that is an important thing to know, that definition. But yeah, so let's go ahead and look at a warm-up. So A here, 2x squared times 5x to the fourth. This is a review of exponent rules. And so I recently did a video on exponent rules. And if you're in my class, we recently discussed exponent rules. So this is a reminder of, okay, what is happening here? If I do something like 2x squared times 5x to the fourth, how does that work? Well, here's how it works. I do the 2 and the 5 together. I multiply them like normal because they're just normal numbers. And then I do the x squared and the x to the fourth together. Since those have the same base of x, I can combine them by saying, okay, x squared is like having 2x's multiplied together, or is having 2x's multiplied together. X to the fourth is having 4 multiplied together. So together we've actually got 6 being multiplied together. So this simplifies to be 10x to the 6th. That is something that we're going to be doing a lot today, actually, is multiplying things like that together. All right, B. Now this is something that should look familiar. We've actually done this in algebra and have done this in the context of like bigger problems. We are going to use the distributive property here to say what is 4 times 3x and what is 4 times -7 and get rid of the parentheses. So the big thing here is to remember that when you have parentheses like this, you multiply both of the things by what's outside. So this is going to be 12x minus 28. So what we're doing in this lesson is multiplying polynomials together. Last lesson, we added and subtracted them. This lesson, we're multiplying them. And hopefully this is not too big a stretch, because to multiply polynomials, all we have to do is use a property that we know and love, that we've already used even in this video, the distributive property. We also need to remember that basically, this is going to sound dumb, but basically addition and multiplication are two very different things. So if I ask you what's x squared plus x cubed, it's a very different question than what is x squared times x cubed. And it didn't maybe like register when we were little bitty kiddos and we're adding and multiplying numbers for the first time, how different those rules are. But somewhere around the time that you started like having to do 2-digit times 2-digit multiplication, whether you thought about it or not, you may have noticed, hey, this is a lot different than addition. This is a lot more work in that particular case. And so then we get to fractions and it's like, okay, I have to memorize completely different rules for adding fractions. I have to get common denominators, and for multiplying fractions. And in that case, though, all of a sudden we switch to where it's like it's actually easier to multiply fractions than it is to add fractions. And it actually is kind of the same reason that we have here. X squared plus x cubed cannot be added together because we don't know what x is. We're trying to say x could be anything it wants to be at this point. We don't know what x is, so if I have something that's being squared plus something that's being cubed, most likely those numbers are not the same. The only way those would be the same is if x is 0 or x is 1. But we want it to be able to be whatever it wants. So x squared plus x cubed, we can't do anything with. We just leave it as x squared plus x cubed because they're not like terms. Whereas x squared times x cubed, it doesn't matter that they don't have the same exponent. All that matters is that they both have a base of x. So we can say, I've got 2x's and then 3x's, and together that makes 5x's. So the difference there is, what do we do when we add and what do we do when we multiply? Now, I want us to think about a question that we don't actually have to do. We are going to use the distributive property to multiply. And so if we had something, a really long problem like this, where we had 4 terms and then 4 terms, I'm looking at this right here. I want you to think about how many things we would actually have to multiply together if what we're doing is distributive property. Now let me actually give you a little bit more information about how we would do this. We're going to take the 2x cubed, we'd do that times 8x cubed, and then times this, that's 2, 3, 4. So just the 2x cubed gets multiplied by 4 things. But now I'd have to do the same thing with the 5x squared, the same thing with the negative 9x, and the same thing with the 10. Essentially, everything in both parentheses needs to get multiplied with everything in the other parentheses. So how many times are we going to have to multiply? Well, if you think about it, there's 4 for this first one, 4 for this next one, 4 for this one, and 4 for this one. So that would be 16 terms. And I'm just pointing that out, not because we're not going to have to do one that is that complicated, but just to kind of point out that like how this is working, that you can actually kind of predict how much multiplication you're having to do, and that will help you hopefully to not forget any of your multiplication. Now, as we're multiplying, there is a thing that comes up again and again and again in math, and that's doing a binomial times a binomial, which is 2 terms times 2 terms. And so because of how much it comes up, even though we can just use the distributive property for it, there's actually a special acronym that we use to make sure we actually multiply everything we need to. It's called FOIL. So this explains my joke at the beginning. Like a binomial times a binomial, I will always FOIL your plans. It may still take a little bit longer for you to get it, but yeah, that's the joke. So this stands for what terms we're multiplying together, and we will do some problems where we FOIL, and so I'll make sure to explain. But the acronym itself here is first, outer, inner, and last. And it's just a way for us to keep track and make sure that we've multiplied together everything that we're supposed to. Let's do some examples. So we're kind of going to start off easy and progress to harder here, just like normal. That's how we do things in math most of the time. So here, this is just doing the distributive property as we know it, except that maybe we haven't done it yet where we had x's on the outside. And so that's what we're adding to it, is now we know how to do negative 6x times 3x. And so what does that end up being? And then we're going to do negative 6x times negative 10. And what does that end up being? And I'm just writing that out to make it really clear to you what multiplication is happening here. Chances are you don't need to write that out each time. You can just think in your head, okay, negative 6 times 3 is negative 18. X times x gives me x squared, so that's the first term of my answer. And then negative 6 times negative 10 is a positive 60, and the x just stays because there's not another x to multiply with it. This right here is my answer, and I'm done, right? So that hopefully is pretty easy. Same with this next one. We're going to distribute 5x squared. So that means doing 5 times 2, which is 10. X squared times x squared. So we add those exponents and get x to the 4th. Then we're going to do 5x squared times negative 4x. So that's negative 20x cubed. And then 5x squared plus 7 is plus 35x squared. And that's my answer. One of the cool things about distributive property that you may have never actually noticed before is that at the end of this, we should not end up with like terms that we can add together if we're only distributing one term. Because if the inside of the parentheses didn't have like terms and we multiply by something, like it still isn't going to be like terms as long as we've done it right. So if you notice like on B that we have x squared, then x, then a number, that's in standard form. Well, then our answer is x to the fourth, x cubed, and x squared, still in standard form, and my exponents are still counting down by 1, basically. So it's kind of a like, oh, this is a neat kind of way to be like, oh, I think I did the exponents right, because they count down like they did before. Let's do example 2. And so we're going to talk about how this acronym FOIL plays in. But the longer I teach, the more I'm like, why is foiling a thing? Because literally you can just distributive property, it's the exact same steps. But a lot of teachers end up using FOIL as a verb, especially in like Algebra 2 and pre-calculus, like whenever you're having to multiply binomial times a binomial. And so I want to make sure that you know what that means, that if somebody says to FOIL something, they're just saying multiply this out. So if you would rather think of it as the distributive property, fine by me. Like literally can't force you to FOIL or use the distributive property because they look the exact same. But here's how we think of it if we're FOILing. We'd think, I'm going to do the first term in each parentheses times together. So the first one in the first parentheses is 5x. The first term in the second parentheses is 3x. So I'm going to do 5x times 3x, which is 15x squared. Then I'm going to do the outer terms. So the ones that are like the most outside in our problem, which is the 5x and the negative 10. 5x times negative 10 is negative 50x. Then we can do the inner terms. So that's the opposite of the outer terms. That's going to be these two, 1 times 3x. And then I'm going to do the last term in each parentheses, which is the plus 1 and the negative 10. Now, when we start doing a binomial times a binomial or something else that like both of the parentheses have multiple terms, we are going to end up with like terms most of the time. And so that means that we need to stop here and say, okay, what is negative 50x plus 3x? And make that extra step of simplification here. And then this is our answer. And again, if you use the distributive property, it looks exactly the same, except that maybe your arrows would look different, right? Because I would have done this and this, and then I would have said this and this. But literally it's the same terms, you get the same answer. So it's really whatever works better for your brain as far as thinking about it. Let's do B. So x times 9x is 9x squared, and x times negative 6 for outer is negative 6x. Inner, negative 1 times 9x is negative 9x. And last is negative 1 times negative 6, which is plus 6. We're going to add these middle terms and get 9x squared minus 15x plus 6. Okay, now we're going to get to the big problem. A binomial times a trinomial. Personally, that's the biggest I normally give people to do, at least in Algebra 1. And so if we think this through ahead of time, if we have 2 terms that we're distributing to 3 terms, that means we're going to end up having 6 things at the end. That means there's a huge likelihood that we'll have like terms to add at the end, and in fact we will. So let's give this a try. I had different letters here and I went and changed it because that's not something I meant to do. That is something that can happen, that we can have different letters, but one thing at a time. So we're going to distribute the 3x to this parentheses. So 3x times x squared is 3x cubed. And then I'm going to do 3x times 2x, which is plus 6x squared. And then I'm going to do 3x times negative 4, which is negative 12x. And then I'm going to stop for a second and be like, I'm halfway there. Then I'm going to do the same thing with the 6. There's a trick you can use to this to help you with the like terms, though, that instead of writing it right after this, I could actually do 6 times x squared and write it underneath the other x squared. And then do 6 times 2x, which is plus 12x, and then 6 times negative 4, which is negative 24. And then as I'm looking at this, I'm just adding in our columns, like what we did with adding polynomials, which I think, makes this part slightly easier, and it's not like we had to do anything extra other than just remember to write it this way. So negative 12x plus 12x is going to cancel out. So there's not going to be an x term, but there is this minus 24. So this would be our answer. And now we're going to do 5y times 4y squared. If you're in my class and you have the notes page for this and it says x is in the second parentheses, just pretend it doesn't and change those to y's, please. Because I did not mean for them to have different letters. So 5y times 4y squared is 20y cubed. 5y times 3y is 15y squared. 5y times 7 is 35y. Then I'm going to keep going and have negative 12y squared minus 9y minus 21. Then add the like terms. These, like any other long type of math problem, can be just frustrating because there's a lot of opportunity to mess it up. So if you are, like, not if, when you check your answers, like, try to pay attention to, like, what is it that you're messing up if you're messing up? Is it just that you keep multiplying wrong or keep adding wrong? Well, that's different than not understanding how polynomial multiplication works. So make sure that you're understanding how polynomial multiplication works, and that will be a good thing. There's two kind of special things that can happen to us as we're multiplying, and that's on this slide right here. This first one looks normal, like a FOIL problem, and we would FOIL this out like normal. The second one, though, looks weird because it has a squared. So I just want to throw these out there as, you know, special things happen, but we can still do them the same way as what we've been doing. 4x times 4x is 16x squared. And then 4x times negative 7 is negative 28x. 7 times 4x is positive 28x. And then 7 times negative 7 is negative 49. Now when I go to add my like terms in the middle, those actually cancel each other out, so that I get 16x squared minus 49. Now the significance here is that if I look at these parentheses and try to figure out, is there a reason why those canceled out? There is. It's the same thing in both parentheses, except one has a plus sign and one has a minus sign. Anytime that happens when you're foiling, the middle terms will cancel, so that you'll just end up with the first and the last term. Different to that is B here. The thing that's super important for us to do is actually say 2n plus 9 squared is 2n plus 9 times 2n plus 9. So if you're thinking, if you looked at this and said the answer was 4n squared plus 81, you're close, but because what we're actually being asked to do is say 2n plus 9 times 2n plus 9, which means foiling, there's a middle term that you have not figured out because you didn't realize it was there. So if you see a squared like that, write out the parentheses twice and then FOIL from there. So 2n times 2n is 4n squared. 2n times 9 is 18n. 9 times 2n is 18n. And then 9 times 9 is 81. So that's going to give us 4n squared plus 36n plus 81. So that's the middle term we didn't know about before. Now we know. Thanks so much for watching. If you are not subscribed, shame on you. Not really, not shame on you. But go ahead and subscribe and just try to, you know, ignore that you're subscribed, and except for when it's helpful. I'm posting a lot of videos these days, but that's not always the case. So I don't know if that's a good thing or a bad thing. But subscribe, like the video, and I'll see you in the next video. Thanks.